Hello, everybody. I'm Tim. I'm based in Belgium. I work at Akamai since 8 years as a web performance consultant. And as Andy said, next to my day job, I also run the largest scale modeling website in the world. And during COVID, many people are at home. So during COVID, my page use actually increased a lot. And last year, I also introduced a new tool called Frustration Index, which is open source. Have a look at that. Now, all these things, they don't really matter today. Today, I want to talk about responsive RUM. And luckily, I don't need to explain what real user monitoring is. Jonathan just did that earlier. And I really love real user monitoring. Why? Because I can really see in all the data how my website behaves under real world conditions. Are people sitting on the train? Are they sitting at home in the sofa on Wi-Fi? Are they browsing in the car? You really see a large variety of data. So that's great. And I can really spend a lot of time zooming in and drilling down in the data. Now, although I love real user monitoring, the big problem is real user monitoring is not responsive. And that's a bit weird because in the end, real user monitoring is very modern. All the real user monitoring tools, or most of them, support Core Web Vitals. Most of them support single page apps. Some of them even support PWAs and edge workers. So real user monitoring is modern, but responsive web design, which is fairly common and since many years, is not taken into account. Let me explain why. So the closest you can get to responsive web design is that you have in every RUM tool a desktop, tablet, mobile classification. Now, this is, in my view, way too simplified. And because it's so simplified, it can actually put you in the wrong direction, or you can even come to the wrong conclusions. So, and this actually worked very well in 2010 when everybody still had an M website and a T website and a www website. But in 2020, where large phones are actually bigger than some small tablets, or where large tablets are actually bigger than some small laptops, it's a whole different story. Also, look at your desk or our desks. I have like this big, not that big, big screen. So it's a big difference compared to 2010. So my point is, in a responsive world, which we are in today, we need responsive RUM. And the good thing is, the things I will propose now are very easy to implement. And in theory, it does not matter which RUM tool you use, you could implement it here. The screenshots I will show now are from my website. So I use Impulse RUM, which is based on the open source Boomerang. And I also use Google Analytics and how is the game called? I forgot the name. I forgot the name. Damn. Yeah, it doesn't matter. Now, before we actually tackle the problem of responsiveness, there is one thing we need to fix first, and that's the device type bias. This is for my website. For almost half of the users mobile, 46% desktop, and neglectable tablets. Now, when we talk about mobile performance or desktop performance, when I say, "Oh, Simon, how is your mobile performance?" then we think, "Oh, mobile corresponds to cellular, desktop corresponds to broadband, and tablet corresponds to Wi-Fi." We know that that's not always true. Everybody knows that. That's not what I'm saying. The only thing I'm saying is that when we look at RUM data, typically when we look at mobile, we just assume that it's a bad connection. When we look at desktop, we assume it's a broadband connection. And all the other tools, this is now a PageSpeed Insights, awesome tool. For example, there you also have mobile and desktop. Mobile is, as you said, it's a phone on a simulated 3G or 4G connection. So again, there, mobile tells the story. Mobile is a phone on a bad connection, while desktop is a good, solid computer on a big connection. Now, If you zoom in Impulse, in Impulse or in RUM, if you zoom in on your mobile devices and then look at the connections, what do you see? 67% uses cable or DSL. I know that's not your phone is not connected to the cable, but that means if you're using Wi-Fi at home, your Wi-Fi is in the end a cable connection. That's the reason why it shows cable. So 67% is cable. Only 26% is actually cellular. Now, what does that mean? Remember, suppose you're looking at the median, like Jonathan did, and like many of my customers also do. And if you're looking at the median, are you then looking at cellular mobile? No. Cellular is typically then the slowest. If you're looking at the median, in your you're looking at a cable connection with a phone, and then you're looking at RUM like, oh, I don't have a problem on I don't have a problem on mobile. Why? Because you're looking at the wrong data. Another example is desktop. 15% of my users use a desktop connected to a cellular phone. This is actually pre-COVID, because when people travel, for example, when I, on the previous talk, I had to take the Eurostar, then I'm working on my computer, I'm browsing the web on my 4G, 3G connection. Some of my customers there live in the middle of nowhere, for example, in some rural areas in the US. There, they just don't have broadband. When they want to surf the web, they just surf of a cellular mobile modem. So that's a thing. Now again here, if you're looking, for example, at the 90th percentile, and you think, oh, why is my desktop performance so slow on the 90th percentile? You think you're looking at cable, while in the end, it's looking at cellular. All I'm saying here is, if you don't apply any of the next tips I will give related to responsiveness, make sure you zoom in on the right connection types so you have a better idea of what you're looking at. Now, responsive design. There are two parts here. First is screen quality. The simple classification, desktop, mobile, tablet, does that take into account screen quality? No. And in 2010, that worked. A pixel was a pixel. In 2020, the iPhone was the first Retina screen. It has a 2x screen. The newer iPhones have a 3x screen. Meaning, and does it matter for performance? Because that's the next question. Let's take this image, for example. A 160 pixels image, a small thumbnail. Because I implement responsive images for 2x screens, for example, I send a picture which is twice as big. And actually, it has 4 times more pixels. Why? You have twice the height and twice the width. Now, what does that mean from a performance perspective? I have 1 million of these different thumbnails, 6 kilobyte, 10.9 kilobyte, 22.5 kilobyte. If you have a search page with, for example, 50 thumbnails, not that much, the 1x version, you send 300 kilobytes, while on the 2x version, you ship 1 megabyte. Is there a difference between shipping 300 kilobytes and 1 megabyte? Potentially, yes. Can we detect that today with desktop, mobile, tablet? No. The good thing is the browser gives you access to window.devicePixelRatio. Window.devicePixelRatio tells you the current device pixel ratio of your screen. And what I did, I created a dimension, a JavaScript variable, which tracks this data, and I send this to analytics, and I send this to my RUM tool. And this is an example, so 40% 1x, 21% 2x, 3x, some strange values like 2.625. This is a very popular Samsung phone, and even 4x and 3.5x. Now, this is for all device types. If we zoom in on mobile, there are a few things you can see. Or maybe the first thing, what don't you see? There is no 1x on the screen. So this is the top 10 list. for mobile devices, today, this is now my website, so for your website that might differ, but on my website, 1x on mobile is irrelevant from a performance perspective. Look at 4x, 3.5x, 3.3x. This is not a bug, 2.549999. It really depends on the screen. Like, for example, the big screen I just bought myself as an early Christmas present, depending on the resolution I look at it, it's 2.2444, whatever value. It's very special. That's just what it is. Now, this gave me some great insights. Now, from a performance perspective, evaluating performance, it has a problem. For example, if I zoom in on 2, like if I want to zoom in on 2x, I only look at 31% of my data. So I lose somehow, or 69%. So one of the problems here with this basic approach is there are just too many different variations. On my website, at least 250 different variants. That's a lot. Now, in the end, from a performance perspective, I don't care about these 200 different variations. If I have some smaller buckets which tell me the same performance story, then it's better. So what I do here is I have a data layer with some additional variables. So by default, I set the DPR to 1x. If the device pixel ratio of the screen is bigger than 1.75, then the browser will switch to 2x. So 1.75, 1.9, 2x, 2.1, 2.5, 2.3, whatever. In the end, I always ship the same images. That's the 2x variant. For screens somewhere in between 1.75, between 1.7 or lower than 1.75 and bigger than 1.25, then the browser will pick the 1.5x version. What does this give you? This was before, too many different variations. This is what I have. In the end, my website and your website, if you have responsive images, they're just, in the end, 3 different variants. In my case, you have the 1x version, the 1.5x version, and the 2x version. The 2x version will show the 1 megabyte of thumbnails on the search page. The 1x version will only show 300 kilobytes. That's how you can look at that data. Now, a few months earlier, I also had a 3x here. Why did I remove it? Because the amount of data I shipped on a phone, which could potentially be on a cellular connection, was just so big, and the quality benefits were neglectable compared to the overhead. And that was because I was really now able to see, oh, that's the amount of data I ship to in that particular version. So very easy to look at. And here you then see the same story for mobile is 1x, only 0.19%. In 97% of the cases, I actually ship the 2x variant for my website. Why? 4x, I ship the 2x version 3.5, the 2x version 2.625, the 2x version this 2.54999, the 2x version. So this gives me a big bucket to validate the performance. So one of the next steps I'll actually do is I will likely ditch the 1x version. Why? I have 1 million different images, and for every product image, I had a 360 pixel image. Why do I need it? Why did I have it? Oh, for mobile devices, a 360 pixel screen on a 1x device. But here you see 1x on mobile is, at least for my website, non-existent. So I will just ship the 1.5x version and save 1 million times a 360 pixel version on my data storage. And this is now a screenshot from Impulse, but so what you then see is, for example, the decoded body size by image source, the first contentful paint, the largest contentful paint, because that's impacted by the amount of bytes you ship. That was the first part. Second part, screen dimensions. This comes from Data Studio. Data Studio was the name I was looking for earlier on. Oh, if my first idea was tablet, desktop. If that's too simplified, let's just look at the screen dimensions. And the first thing you see is there are many of them, and they're really, really a lot. So the same problem as before, cardinality. Another problem is if you have a 32-inch screen and you resize your windows, it also impacts what you're loading. Another issue is some of my users, for example, on tablet, while by default I would ship the small version, sometimes they prefer the desktop version. So if I just look at tablets, portion of them look at the tablet version, a portion of them looks at desktop version. So I want to be able to zoom in on the right thing. So let's look here. So how did I do this? In the end, here you see my website, a beautiful car, and this is what I call the design breakpoint. This is the version of my website, 720 pixels. That's the amount, that's the main content area with a large sidebar. If the screen is like a little bit smaller, in the end, I still ship the same version. It's the same image, the same content. Yes, the white area on the left and the right is different, but from a performance perspective, the amount of bytes I ship, the amount of requests I have, the amount of third parties, the code, it's still the same. Make it smaller, still 720 pixels large, still 720 pixels large. Here also, making 1 pixel smaller, still 720 pixels large. At a certain point in time, my CSS breakpoints decide, oh, I don't have enough room for a large sidebar, so I switch it to a small sidebar. A few things which are different. Instead of showing 2 ads, I show 1 long ad. And instead of showing, I don't know, X small thumbnails, I show a few less. Is that, from a performance perspective, potentially different? Yes, because now the requests change, the bytes change. That's one thing. If you go a few steps further, at a certain point in time, the sidebar goes away, like on many websites. But the main content area is actually still the same as the huge version. It's 720 pixels, and all the rest stays the same. And then I have, if you make it small enough, at a certain point in time, I switch to the 540 pixels variant. And at a certain point in time, I switch to the 360 pixels variant. Taking into account, of course, DPR. So the 360 pixels image is actually never used because I typically will ship the 720 pixels version. That's it. Here is my code. So I take the scroll width of the screen. Why the scroll width and not the viewport or not the device width? Because it depends on what people, it depends on if people resize their window, yes or no. On some of my customers, they actually, when they ask for the desktop version on some screens, that will actually mean that they have a scroll bar at the bottom. From a performance perspective, I still load the full version. So what I'm doing here is based on the breakpoints, I define labels which are meaningful to me. Now, key here is I have more breakpoints in my CSS. For example, between 540 and 360, I hide a button or I change the font styles a little bit because it's better for readability. I don't go for every single breakpoint. Why? Because from a performance perspective, they don't really matter. It's more the key things, where does my content change? What would you see there? Design breakpoints, 54% of my users downloads the 720 version design. And 30% of them, the small version. And here you see this neglectable 0.19%. This one will actually also go away very, very soon. If you then zoom in on mobile, what do you see? 94% of them uses a 360 pixels version. But still, that means 5% or 6% use a larger version. Again, the bias we have, oh, mobile is a small screen on a bad connection. What you're seeing here is people requesting the desktop version. Maybe people putting their phone in landscape mode instead of in portrait mode, or the other way around, that triggers a different version which is loaded. Yes, it's the same device, it's the same dimensions, the same quality, but from a performance perspective, I want to look what is the performance of this variant of the website. And here you then see an example, again, for my different designs, zoomed in on mobile and cellular. I can then validate how many bytes do I ship. Of course, the 720 pixels version is potentially slower. Why? Because I ship more bytes. Now, this is an optimized page, but yeah, depending on your website, that can really differ. So today, RUM is great, absolutely. But if you're just looking at the basic device classification, you are limited to your options. My idea is, at least add connection in your analysis, and if possible, add additional dimensions for the image, for the screen quality, as well as the screen dimensions. And if you do that, you'll be very happy with all the data you have. Thank you very much for listening. And are there any questions or feedback?